Hello everybody. As requested, I am up with a video about nomenclature of coordination compounds. So first of all, we will be going through the rules. Now the first rule says, while writing the name of the complex, the name of the cation is written first. Now we will not consider whether the ion is a We will not consider whether the ion is a simple ion or a complex ion, whatever it is. But the name of the cation will be written first. For example, here we have K4FeCN6. So the cation is potassium. We will write the name of potassium first. In the second case, we have CONH3 Cl3. Here the cation is CONH3 So we will write the name of the coordination complex CONH3 first. There may be cases where both the ions, the cation as well as the anion, both are complex ion. In that case also we will be writing the name of the cationic complex first. So first point, make it very clear, whenever start writing name of the coordination compound, you have to write the name of the cation first. First point. Then comes second point, which says the simple ions like Na plus, K plus, Cu2 plus, they have simple names: sodium, potassium, copper, or chloride, nitrate, sulfate, etc. when present as a counter ion. Then, when we are to write the name of the complex ion, first of all we will be writing the name of the ligand and then the name of the central metal. In case there are more than one ligands, more than one type of ligand present in the complex, such complexes are known as heteroleptic complexes. So, we will be writing the name of all the ligands in alphabetical order. Make note, numerical prefixes will not be alphabetized. Then comes naming of ligands. So, anionic ligands always end in O and cationic ligands end with IUN. However, there are certain ligands like H2, CO, NH3, etc. which have special names. So please make note. We have a table displayed here. It is giving you the names of the ions. Now, the anion's name is always ending in E. So we remove the word E. We remove the letter E and put O. So bromide becomes bromido, chloride becomes chlorido, fluoride becomes fluorido, cyanido, hydroxido, carbonato, nitrato, and so on. Few more are on the display. See, NO2. It is an ambidentate ligand. So while writing the name of such a ligand, we have to mention the donor atom. For example, if it is written as NO2, whichever atom is written first is the donor atom. If it is written as NO2, it means N is the donor atom. The name will be written as nitrito-N. And if it is written as ONO, it means oxygen is the donor atom. Then the name will be written as nitrito-O. Similarly, sulfate becomes sulfato, sulfide becomes sulfido, oxalate becomes oxalato. Ethane 1,2-diamine, no special name, it is a neutral ligand. Similarly, EDTA has no special name. PPH3, please remember this. This is triphenylphosphine. And then comes this C6H5N, known as C5H5N, known as pyridine. Now, in case same type of ligand is present more than once in the same complex, then we use numerical prefixes to indicate its number. For example, if some ligand is present twice, we write di. If it is present thrice, we write tri. It is present 4 times, we write tetra, and so on. But in case the name of the ligand already has a numerical prefix di, tri, tetra, etc., then we will be using numerical prefixes as bis, tris, tetrakis, and so on. Then comes naming of the central metal. So as long as the complex is a cationic complex or the complex is a neutral complex, we write the name of the central metal as a general name which we write in chemistry. But in case the complex is anion, the name of the metal is followed by a suffix ate. Like zinc becomes zincate, platinum becomes platinate, copper becomes cuprate, iron becomes ferrate, and so on. After writing the name of the metal, we write the oxidation state of the central metal in a small bracket. See, here we have the name of the metal when present in cationic or neutral complex, that is chromium. In anionic complex, it becomes chromate. Zinc becomes zincate. Aluminium becomes aluminate. So we write the suffix ate after the name of the metal. Generally, the name used is the Latin name. Now see, we have a complex written here, K4FeCN6. K4FeCN6. So while writing the name, we will write the name of the cation first, which is potassium. Remember, the name of the cation does not contain any numerical prefix if not a complex ion, and this is a simple ion. So we will not write tetrapotassium, we simply write potassium. Now we will be writing the name of the complex. Now in the complex we have FeCN6. So the ligand is Cn minus. Name of the ligand is cyanido. Number of ligands is 6. So it becomes hexacyanido. Then the central metal present is Fe. But since we have a counter cation, it clearly indicates that the complex is an anionic complex. Therefore, the name of the metal will be written as ferrate. And then we will determine the oxidation state. Now the oxidation state of cyanide is -1. Let the oxidation state of Fe be X. On calculating, we find it out as +2. So the oxidation state will be written in small bracket as 2. Now the name of the compound will be potassium hexacyanido ferrate 2. Another complex on the screen, children. This is a heteroleptic complex. We have more than one types of ligands present here. So we don't have any counter cation, which means that the complex itself is the cation. So we will be writing the name of the complex cation first. So in the cation we have two ligands, amine and chloride. Now alphabetically, amine is preceding to chlorido. Therefore, the name of amine will be written first, followed by the name of the chloride. Now we have 4 NH3, so it will be written as tetraamine. We have 2 chloride, therefore it will be written as dichlorido. Amine is written first because A comes prior to C. While deciding the precedence, we will not consider the numerical prefixes tetra or di. We will only consider the name of the ligand as amine and chloride. So for 4 amine it becomes tetraamine, for 2 chlorine it becomes dichlorido. Then comes the name of the central metal, which is cobalt. Since it is a cationic complex, we don't have to write any special name. It will be written as cobalt only. Now calculation of the oxidation state. The oxidation state of NH3 is 0 and the oxidation state of Cl is -1. When we put these values and calculate, we will find the oxidation state as +3. And the counter anion is also present there. Now remember the counter anion or the counter cation. Neither of the two have a numerical prefix. So if we have only one chlorine, then also we will write chloride. If there are more than one chlorine, then also we will be writing chloride only. We won't put any numerical prefixes for counter ions. Then comes the name. As you can see, we have 4 amine, so the name becomes tetraamine, 2-chlorine, dichlorido, cobalt, oxidation state is 3, and after that the name of the counter ion, chloride. So the name is tetraamine, dichlorido, cobalt 3 chloride. One more question, this will be the last question for the video, children. We have a complex which is CrEn whole thrice and CrF6. Here we have both the cation as well as the anion present as the complex ions. Now, for naming the complex cation, we will consider the ligand En is ethylene diamine, proper name is ethane 1,2-diamine. Now since the name already has a numerical prefix di, to indicate 3 we will not be writing tri, rather we will be writing tris. So the name of the ligand becomes tris. Then in a small bracket we will be writing ethane 1,2-diamine. Then the central metal, chromium. Oxidation state, since the complex is a charge of 3 plus and ethane 1,2-diamine is a neutral ligand, so the oxidation state of chromium will come out as 3. So it becomes 3. Now we will be writing the name of the anionic complex. In the anionic complex we have fluoride ion and the number is 6. So fluoride is written as fluorido, and since we have 6 fluorine, the prefix will be hexa. So the name becomes hexafluorido. Then the central metal, chromium. But since this is an anionic complex, chromium will be written as chromate. Chromium will be written as chromate. And the oxidation state of chromium will be calculated using the oxidation state of fluorine as -1. On further calculating, it comes out as +3. So it becomes 3. Now we will be writing the name of the complex cation followed by the name of the complex anion. So it is tris ethane 1,2-diamine, chromium 3. Then the name of the anion, which is hexafluorido chromate 3. Now this is the name of the entire compound. Hope you have understood, children. In case of any problems, please communicate through the comments in the video. Thank you.